We are in another mechanical room with another brand of boiler, and we can see that the boiler, the setup is pretty much the same. In this case, we can see how the gas drain, we have our regulator just like in the other setups. We have a redundancy with our two power heads that will open and close the main gas valves. We have our isolators or valves here to stop the flow of natural gas, and we also have our high limit, and we have our operator and our differential sensor that was used to anticipate the operation or the temperature and operate the boiler. But note that these are not in use anymore, and the reason why is because just like in previous videos, we have our modulators that control the rate of natural gas and the amount of air that goes into the burner for combustion, and we can see that the rate is determined by this controller again, and we can see right now that the air temperature is 8 percentage, it's 8.9, and the fuel is 11.6, and we can see the position on that curve from 0 to 100, and basically that's how the system controls capacity on this boiler. Instead of having low and high fire, we can have any number of different positions from basically low fire to up to 100%. In this case, it's calculated to be anything but anything other than low fire. And we can go in the back. We can see the boiler, the other boiler, which is not operating right now. It's in standby mode. We can see our controls on this side pretty much the same as previous videos. We have our fire eye control board that will operate the boiler. We have our starter, we have our transformers, we have all the switches and relays that will enable and disable all the different components based on the call that it gets from the system. We can also see our gauges that tell us the pressure inside the boiler and also the water temperature. And if we go to the back, we can see how we have our combustion dampers that will open and close based on the call received from the system and allow combustion air to go in the mechanical room and provide combustion air for the combustion process inside the boiler. In the back, we can see our different valves that control the flow of water in and out of the boiler. Same thing for this boiler, and we see our relief valves that will open and basically when there's an unsafe condition. We just heard how this boiler reached the set point and is going down to the off position, and we can see how the air fuel ratio also changed, and now the boiler is off. Let's go back to the back of the room. We can see that the combustion dampers just closed because the boiler is not in operation. We don't want these dampers on or open all the time because there is no need to have air flowing in, especially if the conditions outside are not appropriate for the mechanical room. Let's go in the back to see the back of the room. We can see our pumps. We also have our chemical feeder and the filters to remove any impurities from the closed loop. We can see our gauge that tells us the pressure of the water circulating, and we also have a bucket of chemical. It means that a technician did some water testing and found that the oxygen levels in the closed loop were too high, and an oxygen scavenger was injected into the system to absorb the oxygen and prevent corrosion inside the closed loop. We have redundancy in pumps. We have two pumps. Right now we only have one running to move the water around the system, and in this case you know, the two pumps are the same, so we have the same flow conditions at all time. We have our control panel, and I don't have a key, but right now we can see that this DX9100 controls from a well-known controls company is in charge of all the points, analog and digital inputs, as well as the outputs that will control the operation of all the equipment found in this mechanical room. So let's go back to this side, and we will see the pressure tank that will allow the water to recirculate through the system at the correct flows. And we can see that it was calculated that the pressure, let's see if I can focus on that gauge, and it's about 32-33 psig, and it was calculated that it was the required pressure to allow the water to move throughout the system. We have the our domestic water heaters here, but we're not going to talk about them. What we have here is a also a chemical heater that we can use to add chemicals into the closed loop, just like I just showed you with the other one. And then let's see what we have here. It's basically that will allow, this tank will allow water to be in reserve, and we have floats right there that when the water goes down for whatever reason, it will allow water to go in through that valve and maintain a level. And then when that pressure in the system comes down due to a leak or another reason, the pump will sense that differential in pressure and allow that pump to operate and inject water and keep the pressure, the designed pressure, at the correct number to allow the water to flow in the closed loop at the correct flows.